Hello, everybody, and welcome to today's device management interface call. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and the information you share. Today, the key topic that we're going to discuss is the combo PON support in Volta and the device management interface, and how the device management interface needs to be extended to achieve this support to allow dynamic configuration of the PON tech. Thanks, Girish from ONF for coming, and I'll leave you the floor.
Thanks, Andrea. Hello, everyone. Okay, let me share my screen. Okay, so I don't know, where should I begin? Should I begin with everything from the start, or just discuss the dynamic configuration? So
maybe a very brief introduction, but then go straight to the point.
Okay. Yeah, so this is a document for combo and any PON support. So we assumed a few requirements for this feature. The first one is it should be possible to statically configure the PON tech on a per PON port basis on the OLT, and then it should be possible to do a dynamic configuration if the OLT supports it from the Volta and device management outbound APIs. And if the OLT PON was dynamically configured, then such configuration should be returned to a non-volatile memory so that it could be applied on OLT reboots. So that is a third assumption, a third requirement. And the fourth one is for any reason, if the PON tech configuration fails, it should be clearly communicated back to the caller so that a corrective action could be taken for that. So that's the fourth requirement. And the fifth one is it should be able to query the PON tech, the logical to physical port mapping for the combo PON from the Volta or device management outbound APIs. And the sixth one is it should be possible to query the transceiver information if again if the OLT platform supports it, so that could be used to configure the PON tech. So if a GPON transceiver is connected, configure the PON as GPON, something like that. So based on these requirements, so these are the high-level work items. One is a static configuration of PON tech. The second one is dynamic configuration. And the third one is the outbound API changes to report PON tech logical to physical port mapping for combo PON. And first, sorry, I'm being quick. Do you have any questions so far? Okay, then. So for supporting static configuration of PON tech, yeah, we have come up with an YAML format that should be, placed at OLT at a certain path where, the OLT process can read it, and then configured the PON ports in accordance with, the PON to tech mapping and ranges that are specified in this format. It's a pretty simple format. It has basically, you define the number of PON ports, then you define the PON ID range. It could be 0 to 0. It could be just one PON port, and then you specify the technology for that particular range, and then the resource ranges for that particular range. Yeah, there are some fine print here. I'll not go into those details. Pretty straightforward. And if the OLT does not support, dynamic configuration, and you want to change the PON tech, you somehow download this file. Volta is not involved in this process. You somehow download this new static configuration file to the OLT, and then you reboot the OLT. So the OLT process then reads this new file, then reconfigures the PONTEC. And there is no change needed to OpenOLT Proto for this because OpenOLT Proto already exposes resource ranges on a per PON port basis. So nothing is really impacted to implement this particular functionality. So as soon as OLT reboots with the new PONTEC, the new resource ranges are reported, and the resource pools are reset up. The ONUs are rediscovered and reconfigured with the new new PONTEC resources, etc. Okay. Now the important part for this particular call, dynamic configuration of PONTEC. So briefly speaking, how it's implemented on the Broadcom Aspen chip, and I know Atran does something similar, is so for implementing combo PONTEC, the Aspen chip has 16 ports, PON ports on the Mac device. So what is done is port 0 and 1 are on the Mac device are combined and exposed as a single PON port on the OLT box. So on the OLT, you'll see one PON port, but behind there are two different PON ports on the Mac device. So you basically multiplex two PON ports to an external facing single PON port. I talked to Atran folks, and they also confirmed that the implementation is similar on their combo PON OLTs. So there is a need to basically provide a mapping of the external physical PON port to the internal ports on the Mac device, because what is there on the Mac device is what is exposed to Volta. Volta does not know about all this two PON ports mapping to external PON port, things like that. What Volta says is ports on the Mac device. So somehow it's probably very important for the operations guys to know how this mapping is applied, because they are the ones who maintain this network, most likely so. Okay, so with that information, so let me go into the sequence diagram on how. Okay, let me zoom this a bit. How dynamic configuration of PONTEC is done. I'm sorry if I have no experience with device management. I just looked at the interface and I have come up with some idea. Please correct me if something is wrong here. So the DMI client first initiates a disable PON for the the external facing PON port whose technology needs to be changed. So disable PON sent to DMI server, and the DMI server sends a disable PON to the OLT process. I just realized probably if you might need to disable two PONs here if it's already a combo PON port. So if you're changing from combo PON to say GPON or only XGS PON, you might need to initiate two disable PON. Yeah, just assume that. So you initiate a disable PON, then you receive PON interface down to the OLT agent, which then propagates to the OLT adapter. And then you have a series of ONU down indications for all the ONUs on those PON ports. So then the ONU down goes to the adapter, and then finally there is a UniPort down at ONOS, and all the flows, schedulers, and queues are removed on the OLT. Now you plug out the transceiver on the OLT, and then the DMI server will initiate a stream event on the streaming channel with the event IDs as event transceiver plug out. This results in delete of transceiver object or container and all its children from the model. here, as far as thanks to Amit, I had some good insight of how things are done on the DMI. So it seems that, the port objects are children of the transceiver object. So you basically delete the transceiver and all the children, from the model. And now you plug in a new transceiver. Then you receive another event on the streaming channel with event IDs as event transceiver plugin. And then you basically create the transceiver, a new transceiver object with all the container. Transceiver object with all its children in the model. Now you enable POM with the new tech. So that basically, the DMI server triggers the OLT process. Assuming it's a success case, you receive a PON interface up. This is, what is this? This is OLT agent. And then OLT agent, reports a PON interface up to the adapter with the new resource ranges, and then followed by ONU discovery, activate ONU. And this is all the process that we already know. There's a UniPort up, then flows, schedulers, and queues are added. Yeah, this is a sequence. There is some fine print here. This is probably very important. So the first one is, the first step is to basically, in the sequence diagram, we saw that we had to disable the PON port. So for disable, you use the set hardware component info. You invoke the set hardware component info API. The component type here is type port. Oh, I think it should not be type port. It should be type transceiver, right? I'm not sure. Okay, I think it should be type transceiver and
probably transceiver, yeah.
Sorry, there are so many minor details. Sometimes and you say component admin state locked. So this basically results in disabling of all the children of that transceiver. And it could be 1 or 2 PON ports. Then the step 2 is, you basically see a PON port going down on the at the adapter and followed by ONU down. This results in all the flows, queues, schedulers, everything getting removed. At step 3, you basically you plug out the transceiver, and this results in removal of the transceiver container and all its port, children port objects from the model. Step 4 is you basically plug in the transceiver, and the model is recreated. And then you set the hardware component info. For enabling, here it should have been the transceiver again. I made that mistake. I should correct here a bit. I assumed it's the the modifiable component here is the port object, but it should have been the transceiver object. Similar to how you disabled the transceiver, you admin state lock the transceiver component type. You should have enabled the transceiver component type. So yeah, I'll change that a bit. I think it should be a minor change here. You basically specify the new PON tech on the transceiver component type.
Sorry, one question. Why do you have to do that? Why do you have to specify the PON technology?
I see what you mean here. You mean probably because it could be automatically detected?
Yeah.
Okay, I see what you mean. Yeah, most likely it's not needed. I mean, if it's detected, then the DMI server would automatically invoke. Okay, but as far as no, you don't need to do that. No, you don't need to do that. Yes, you're right.
Well, isn't that the requirement is that if it's not detectable or the transceiver cannot really upstream or like we cannot tell which tech is the transceiver, I think we should allow the system to receive a configuration for that pawn. Isn't that what we discussed yesterday, Girish? Or am I off the point?
Yeah, we discussed that. So basically, Andrea and me were talking that if for some reason the transceiver type could not be detected, the DMI client could go ahead and invoke the set hardware component info on the transceiver object with the new pawn tech, and the DMI server could just ignore that. I mean, if it already has detected, but for some reason it has not detected, it could, take in this request and configure the transceiver object with the new pawn tech. Does that make sense?
Yeah, I mean, because currently, we do not support, at least Adtran does not support this hardware component info set request. And I mean that this is a new parameter, this pawn tech change attribute, right? So,
well, the thing is that, Holger, I believe you can say unsupported, but it's because Adtran supports the dynamic discovery. If somebody doesn't support the dynamic discovery, it should offer the set capability. So I think the set capability should be there. It's just that people will maybe not going to use it because it will be auto-detected.
Okay, so I mean this would be fine for me. So the intent is not that you have a combo transceiver and you will only enable GPON for it. This is not the intention. You have a combo transceiver and then you enable both technologies.
You could say combo.
Yeah.
Pawn tech.
Yeah.
Oh, sorry, I lost. Go ahead.
Yeah, so I think I wasn't sure if you want to just use that for limiting something, like in the combo transceiver, you only want to say, I only want to have GPON. But this seems to be is not the case. So you only want to use it in case that you cannot detect it automatically. Then you have to, okay, this is fine. Yeah.
So I have one comment here. So the problem that I see is that when the hardware comes up, right, it has to detect that there is a transceiver because the inventory is created by the device manager, right? So maybe it is possible that it cannot figure out the type of the transceiver, but it has to create the transceiver object, right? In the inventory or in the tree structure that the device manager maintains.
Yes, right.
Could we say unknown? It's just throwing out an idea.
And does the transceiver object already have a pawn tech attached to it? Oh, it does.
Yeah, the transceiver has. So
there is a type unknown here. Probably, I think probably this is used if it cannot detect the technology. And that is where we could use the set hardware component info API to set the technology. Does that make sense?
Yeah.
But I mean, wasn't there something said that these 0 values shall not be used? Or am I wrong? Yeah.
Yeah, ideally the zero values for the enums in the protos are not to be used. They are supposed to indicate only an error.
Hmm.
So
Do we move it to 1?
yeah, we could create one more enum value.
Okay.
Should.
Yeah, and I don't know, not detected, but probably that means the same as type unknown.
Can't figure out. So anyways,
Yeah, so the DMI client would invoke the API. I mean, the DMI client and server, work together, right? I mean, the vendor who wrote the DMI server also probably writes the DMI client. So
no, but Girish, I think I explained to you the problem. The other problem that I was trying to say, right, is that, see, you have a GPON transceiver, right? A real GPON transceiver. And if you want to change, right, then if you plug out the GPON transceiver, then the GPON object from the inventory goes away.
Right.
Right. And a new object gets created in its place.
Right.
So changing it on that transceiver does not make sense, right?
Yeah, right. So that is what Holger's point was also. I mean, if the technology is already detected, I mean, you don't need to trigger that API. What you could do is, get hardware component info. If you see that technology type as a properly valid technology set there, you don't need to do anything. But you use the API only when in cases that your platform does not support automatic detection of PON-tech of the transceiver.
So what happens in case of BAL?
BAL itself does not provide APIs to detect the transceiver technology, but you have something called the ONLP utility, which basically provides mechanism to read the EEPROM memory.
Okay.
And this is compliant to some specification, SFF 8742 or something. And I don't know, they use that to somehow detect the technology that I'm unsure of how yet. But yeah, I mean, it's basically, yeah, it's that way. I don't know how Atran does it, but on white box OLTs similar to like Radisys or EdgeCore, they use the ONLP utility.
Okay, so through the BAL APIs, when we are configuring the interfaces, right, at that point of time, we have to say that we need to configure it as combo or GPON or XGS-PON, is it?
Yes, you have to specifically configure it. I mean, that is not something automatically detected. Someone has to trigger these APIs. BAL does not automatically detect it.
Okay. And okay, so the user of BAL, which is the app, right? App needs to know that on which slots the transceivers are there.
Yeah.
And then configure it accordingly.
Right. I mean, I have not tried, with the GPON configuring XGS-PON. I have not tried that. I know what will happen. But yeah, but there should be the right transceiver, and you should configure the right technology on that output.
Okay.
Yes.
Yeah, sounds fine to me. I think so. Basically, what we are saying that is that when the DM detects the hardware or the components, if it does not have capabilities of figuring out the type of the transceiver, right, it will mark it with some new to be defined enum value,
Right.
whatever, undetermined or something like that, right? And then it is up to the DM client to go and change the transceiver type
Technology, yes.
technology for that particular transceiver, and which will give an indication to the OLT, right? Basically to change or
Yeah.
to do the configure the port accordingly.
Right.
Right. So the workflow for putting it in admin down and all is not needed, right?
No, you still need to do, I mean, I
See,
have.
if you don't know the technology, there is no way the port is operational.
Yeah, it's not operational. Yes, right.
So we don't have
That's
to
a
do
fair
any
that's a
admin
fair
down or
point.
anything.
Right.
That's a fair point, Amit. Yeah.
Yeah.
But what happens when you want to change it? Because this is the startup, but then the same pawn, given that we cannot detect it, it must always be changed if we want to change it.
So for changing, I would think, just thinking aloud, the workflow should be that you just go ahead and plug out the transceiver that you want to swap out and plug in the new one. And this new one should now show up on the device manager interface. And because the OLT cannot determine its type, the DM client again goes and says, okay, this new one that is showing up is a XGS pawn, for example, that I plugged in. So he goes and changes it to XGS pawn, and then it becomes operational.
Right. You still have to, I mean, that should also trigger the enable pawn on the OLT process.
Yeah, internally it will do that, right?
Yes. Yeah.
So whenever you move from that, say, undetermined to a specific technology, right? It would
right.
Yes. So so the thing that you would have to change is on the transceiver, and when the transceiver is in that type is undetermined, it will not have any children because it can't create ports, right? There wouldn't have been any ports created.
Right.
So only after you set the technology to something specific, it would be able to create the port, and that port would show up in Volta as well as the port should show up in the DMI interface.
Right. So the change would be here. So you receive transceiver plugin, the model is created here. And if your platform does not support automatic detection of the PON tech, you basically enable PON with the new tech. And then that enables, and then you basically create the children here. I mean, if it does not support automatic detection, I mean, this is the point where you would basically create the port children on the transceiver parent. If it has automatically detected the PON tech, then there is no need to invoke this enable PON with new tech because it has already detected the PON tech and it's going to enable the PON ports. Is that correct?
Yeah, I think that sounds okay to me.
Yeah, I still have a question, which is a little bit different. Why do you have to disable and enable it at all? Why you just don't? Why isn't it just possible to just pull it, and then the PON goes down, and then you plug the new one in? Well, why do you need this disable PON?
This one?
Yes.
Again, I see the cause of confusion here. This should have been disabled transceiver.
Yeah, but again, I think that's the same question. Why do you have to disable the transceiver? Why?
I see.
Isn't it sufficient to just plug it out and then plug it in again?
Right. You're absolutely right there. Yeah, that should be possible. Let me simplify that. I think just disabling, just removing the transceiver should invoke all these procedures automatically. Let me see that. Yeah, that's a valid point, Holger. Let me correct the sequence diagram.
But if it's valid, then why is it needed? Sorry, I'm a bit confused. It's probably my side which is confused.
It's
yours,
not,
but,
I mean, I probably overthought it and put all these, sequence diagrams here. So, the plug out transceiver could actually move a few steps above, don't need to invoke disable PON. You just have, plug out a transceiver, action here, and that would automatically trigger, you basically remove this step and have the plug out transceiver here, and that would automatically trigger disable PON. I just overthought a bit. Does this make sense? Similar to how a plug-in transceiver, triggered all these events, you just need to move this plug out a bit up in the process. Okay. Any further comments before I discuss the further steps in this? I don't think there is much left here. Plug in new transceiver. Yeah, I think I'm at the last step here. So the final step here is, the interface operation indication is reported after the new PON port is up with the new tech. And this is towards, the adapter, the OLT adapter. Here it indicates that the PON tech is updated, the new technology, and the new resource ranges. I mean, the ones highlighted in yellow.
Sorry, Gireesh, I have a question on this one. So the port ID or the interface ID, right, is going to be different, right?
So it's not going to, so if you change from combo to just GPON, or if you change from GPON to XGS PON, yes, the port ID is going to change, but it doesn't matter. I mean, if that port was never initialized, I mean, the port is still reported, but it will be down. So
so let me take an example, right? Like the other day. So say physical port 0 is combo. So you have PON-0 and PON-1, right? And then on physical port 1, you have, say, a GPON transceiver. So you have PON-2. Right? Now, if you change the GPON transceiver to a XGS PON transceiver, the port will not show up as PON-2, right? It will show up as PON-3. Right? So then why would we ever need this PON tech updated? Because each of those ports will be different. So PON-0 will always be GPON. It can be up or it can be down. Or it might not be present altogether, right? But the tech of PON-0 can never be anything else apart from GPON.
Okay, yeah, I see what you mean.
So technology being reported is fine. You need to say, okay, what is the technology of this port? But the tech cannot be updated, right?
Yeah, for BAL, at least I know that you cannot, the technologies for the, ports on the Mac device is fixed for a combo PON case. So it cannot change.
Yeah, maybe we might not need that.
I from the discussion I had with you, Adtran also does not need this. I mean, the technologies are fixed. You said something like 0 to 15 is GPON, 16 to 31 is XGS PON.
Yeah.
Okay. Yeah, I don't think it's relevant, but it's not harmful either. But I mean, it does not even make sense from what we discussed, at least for the BAL case.
Right. Yeah. Yeah, so think over it, and if there is, maybe if you're not missing anything, then yeah, we could remove it. But yeah, if we are overlooking something, then we could still retain it if there are some use cases.
Okay. Yeah, that is all. I mean, so once these new resource changes are reported, you basically reinitialize the resource pool. And then as soon as the ONU is discovered and when it's being activated or flows are being installed, you basically allocate resources from this new resource pool. And okay, the final section is the exposing combo point information via DMI not found APIs. Actually, there is nothing to be done here. So you basically have this a component with there is repeated component children. So if the component type is transceiver, the children are basically the ports on the MAC device. In this case, the port has a mapping label that indicates to which transceiver this port is mapped to. So you basically can find out the relation, and this port mapping label is actually the PON port name that is also seen in Volta. So you can actually map which PON port label that the Volta sees is actually mapped to which external facing PON port. So you can actually find all these mapping through the DMI interface. So there is no change actually needed to find this mapping. It already exists. So that's what I was trying to say. Yeah, I mean, that's all I had to discuss. Any question?
So maybe, so I think if this is all good for everybody, I think we can think about the next steps, which is for probably you, Girish, I think it would make better sense to update the DMI protos with these changes that you suggested, and for us to review the patch. Then a possible sample use case would be BBSIM, to implement this on BBSIM. And that could also showcase and try out the set, because BBSIM we could mimic the fact that we could not know the type of the transceiver, so we could try the set there as well. And yeah, then I think that the Atran folks need to implement it into their device manager. And at some point, when we're going to have the open source device manager, we're going to do it as well.
Yeah.
So one question, Andrea. So
Yep.
why wouldn't we try to implement the learning of the transceiver type in the OpenOLT agent?
I have not mentioned any of that. So that is the case, but here it means that we will not be able to generate the events and things like that in the open source implementation. You will just get what you get, and that's it.
No, sorry, I didn't follow you.
That at the moment, the open source implementation of a device manager does not exist.
Correct.
So those events that Girish was talking about are not there, and we don't have any capability to push them at the moment into the open source solution.
No, what I'm saying is that if the if the agent can be enhanced to learn the tech of the transceiver, right? Then
Mhm.
everything happens inside the agent and on the box itself, and no change is needed anywhere.
No, I agree. I
Yeah.
agree. I mean, the thing is that if we wanted to publish some of those events that Girish was talking about, or if we want to be capable of configuration or retrieval of the information that Girish presented today, it's just not there. It's not going to be there in the open source. We can still achieve the functionality of plug and play combo PON, plug and play different type of PON technology, but some of the things that we presented today will not be there.
Yeah, I get that, because why I'm suggesting is that, see, if you look at it from an operator's use case perspective, right? If it can be plug and play, I think it helps them a lot. Right?
Indeed,
Rather than like
indeed.
configuring each and every transceiver that they plug in.
Indeed, indeed.
Yeah, so. Yeah, but yeah, I think the capability would exist for both the options. Yeah, you could configure it, or it could be auto learned. Yeah.
Okay. Yeah, I have a few actions as discussed. So one is what Holger suggested, move the plug out transceiver. I mean, there is no specific need for disable PON. I just move the plug out transceiver at the beginning, and I need to change, some of these wordings here. This should be enable transceiver with new tech, not enable PON with new tech. And again, this is applicable only for cases where the OLT cannot detect the transceiver on its own. I mean, things like that. And also some of the things here, it should have been transceivers. So I have few notes, and I will correct them in this document, and I'll recirculate that.
I thought a little bit about the this disable PON we were talking about. I mean, the problem currently is that you have to configure the PON type somewhere in the management system, which is on top of the device manager, right? So at some point in time, you have, so for example, you plan to exchange a GPON transceiver by a combo transceiver. Then before you do it, then you have configured GPON as a type in the management system, right? I mean, and we're supposing we're not having the possibility that it's auto detected, so you have to configure it. So this means that in the management system, so you will plug your GPON transceiver in, and it will be shown up as unconfigured or type unknown, whatever. Then then you have to configure in the management system the type of the transceiver, which is GPON now. Then the device manager will configure this type, and then it will show up as a GPON transceiver. But then if you want to exchange it, if you would just plug it out and plug in a new one, which is now a combo transceiver, then the management system would still configure it as a GPON transceiver, right? So you have to change this at some point in time. And perhaps this is when you need the disable, because you have to disable it first. Then you have to configure the new type, for example. Then you can plug it out, plug the new one in, and then you enable it again. Because if you're not using the disable, you are in a somehow transitional phase where you still have the old type configured, but you already have the new transceiver. You know what I mean?
Yeah, I get your point. Yeah, my knowledge, outside the system is very limited. From an operational perspective, I see the problems that you mentioned.
No, I mean, it's the same for me. I don't know anything about the system above, but I'm just curious, and I'm thinking this might be a problem, because if I mean, for example, if you just plug out the transceiver and plug it in again, the same transceiver, then you would probably expect that it will be configured as GPON again, right? There's no intervention needed by some operator. This should happen somehow automatically, but if you replace it by a different transceiver with a different type, then it shouldn't be configured automatically. And that's why it would be, I think, better what Amit proposed, that it's somehow done already in the OLT agent, because then you don't have all this mess in the management system. Yeah. Sorry, I'm just thinking aloud.
Yeah, that's good. I mean, both approach, living outside the outside system, I mean, both approaches look good, but at this point, I don't know what is the right one. What I have proposed is also neater. I mean, you trigger something from the DMI client. Probably the DMI client receives the disabled PON from external system. The DMI client is not doing things on its own. There is a user sitting behind the DMI client.
And not everyone has a DMI client and a DMI server. So I think what is the DMI client actually? Is it somebody using the DMI interface?
Yes.
Or
yeah, someone who is talking to the DMI server. I mean, I just put that name. I don't know what you guys call it.
Yeah, because we also had some discussions. There are other possibilities that the DMI server runs on the OLT, and there's a DMI agent. Sorry.
For now, I mean, if you see this,
okay, so here the DMI server is running on the OLT. Okay.
Yeah.
Because in our case, in the Edgerun case, it's always running outside of the box. It's not running inside the box.
Okay, then how does it? How does it detect the transceiver change? I mean, the OLT process is going to talk back to the server sitting outside the box. Okay.
Yeah, I mean, we are using Netconf for management, and Netconf supports notifications, and we're getting a notification for a transceiver plug out, plug in event. And then then the DMI queries the type of the transceiver, and then it will report a new hardware as part of the inventory.
Okay, so considering the point that you just brought up, I think this seems more cleaner approach. The client issuing a disabled PON because this is some operator or some operation who is doing this. You clean up the OLT system, you disable the transceiver, and then you plug it out. Probably seems cleaner to me. I mean, considering what you just mentioned, which made sense.
Yeah.
Oh, sorry, but a disabled PON cannot destroy the transceiver object in the DMI structure, right?
It will not destroy. It will get destroyed only when you plug out the transceiver.
I thought it's only setting the administrative state to locked or something.
No, but when you just remove the transceiver, it basically deletes the transceiver object from the model, and in that case, I don't know. Probably in the operator EMS system, you don't have that object at all, right? I mean, you said initially it is configured as GPON, and then you're going to change it to combo. But once this object is removed altogether, slightly confusing. I mean, what happens with the EMS?
Yeah, perhaps Amit should know best what is happening if you.
Yeah. So see, if you plug that out, right? So first you should get a plug out event, right? And then this would be missing. And when you plug in a new one, right, you will get a plugin event, and then you will find the transceiver object again. Now, the object earlier versus this one would be different because they're two different transceivers. Right? They might have a different, I don't know, serial number, they might have a different version and blah, blah, the attributes that are there for the equipment or a component, right? And based on that, the operator somehow needs to, based on some of the information that is coming there, right? The operator needs to figure out that this is a GPON or an XGS PON transceiver, right? Else, if the operator has to manually figure out that, okay, this OLT on this physical port, this is the transceiver, that is going to be too much of a headache, and it's going to be manual, right? So ideally, it has to be automated. Even if the operator is setting it in, it has to be automated, which would be based on some characteristics of the transceiver that is being learned. So maybe it is the serial numbers, or I don't know, the model, right? So out of some of those values, the operator knows, okay, these models are GPON or these models are XGS PON. And when a transceiver plugin event comes, he looks up on the transceiver and sees, okay, the type is shown as undetermined. So that means the OLT does not support detecting the type. So I need to set it explicitly. So he looks up on the model, finds the mapping as to what the type of the transceiver is, and then maybe sets it. So that could be one option. And the expectation would be that once it is set, after reboot of the OLT/device manager, that information is retained, right? Or else every time the thing comes in, it needs to be checked. If the type is undetermined, then set it again.
Okay.
So effectively, it opens up quite a few workflows, right, in the management system, and that's why ideally, if it can be done in the box itself, I think it makes life much more easier. But I think what we already discussed is, yes, where it is not possible, we should have this option. And yes, the problem statement then moves to the operators management systems as to how they set it.
Okay. Okay, so, sounds good. So Amit, again, just to confirm, so it should be automatically detected. So I'll still go ahead and do the change in the document to plug out the transceiver, and then that is automatically detected and PON port is disabled. So that's the change that I'm going to do. Okay. Okay, sounds good. Any other comments?
So this plug out and plug-in on plug-in of SFPs. So how would that be supported through BAL? Again, it can't be BAL, right? It will be some ONLP that is going to support that.
Yes. Yeah, BAL does not provide any mechanism to do that. Yeah, somehow the ONLP has to be integrated to the agent application to provide this functionality.
Yeah. Because this functionality is absolutely needed, right, to give an indication to the operator that a plug-in plug-out is happening. Because if the device is not capable of setting it automatically, then this indication is absolutely must, else the operator wouldn't know, right, that when to go ahead and do that. Yeah.
Yeah, we have Andrea, probably Andrea can comment. I don't know if we can achieve this in, I mean, that's a target to achieve this in release, but I don't know if you can.
So originally it was not a target. Originally the target for 2.10 was the design of this. Obviously, if we can make it, it's great. If we can't, that's okay.
Yeah, I mean, two things, I mean, for ONF, I mean, Atran has their combo upon OLT, but I mean, we need a combo upon OLT for us from HCore or Radisys, and then I mean, then there is also significant work there to implement those, do the ONLP integration, so many things.
So I think that there we could leverage some help from our existing partners. We do have a combo from Atran that we can test the rest of the stack with, and then we can get some help from Radisys because they do have what I believe is an already working version for the OpenOLT agent.
Okay.
So we can get some help there. Okay, I think we are at the top of the hour. So Grish, if you don't mind, please submit a patch for all the things that we discussed today, and also update the documentation, and then we can take it from there. I guess the next step is to investigate the ONLP support for all of this.
Yeah.
Okay.
Yeah.
Thanks, everybody.
Thanks,
Thank
everyone.
Oh, go ahead. Go ahead.
Yeah, sorry. What I was trying to say is ONLP just API just reports the EEPROM 256 byte memory data. That's it. We have to decode that EEPROM data to find out the details of the transceiver. All it does is just give back the EEPROM memory data. That's it. Yeah, that's what I was trying to say. Anyway.
Okay.
So I have to drop for another meeting.
Okay, sorry.
Thanks, guys.
Bye-bye.
Have a nice day.
Thanks, everybody.
Bye.
Cheers. Bye-bye.
Thanks, everyone.